All right, so today's topic is wetlands. So these are areas of land that are covered by water at least part of the year. So what do wetlands do in the ecosystem? What's their job? What is their role? Their purpose is to prevent flooding by holding water much like a sponge. And we have talked about this sponge over and over again. We've talked about it in previous units, and then we talked about it a lot in the water cycle, this unit, okay? So they prevent flooding by holding water much like a sponge. So natural water quality improvement, it also helps. Shoreline erosion control, fish and wildlife habitats, natural products for the economy, which include things like shellfish, timber, blueberries, and medicine. So up here shows us a picture of how wetlands actually work. Okay, so we've seen a few diagrams similar to this throughout this unit, but you've got your groundwater flow. So the groundwater is always where? In the ground, right? Okay. You can see how it dissipates stream energy. So you've got flowing from the stream, okay? And then it goes here. And then this is where the contaminants and sediment are filtered, okay? It also provides critical wildlife habitat. And then once this runs through here, this is where the cleaner water will flow out, okay, back into another stream. A lot of definitions in this unit. Another one being wetland loss. So if we're talking about the loss of something, okay, it's going away, we're losing it. So this is a decrease in wetland area that is due to the conversion of wetland to non-wetland habitats, okay? And this is due to human activity, so things that we do. The United States alone has lost more than half of its original wetlands, and we continue to lose over 100,000 wetland acres a year. And this is due to things that humans do, so human activity. Next, we're going to talk about wetland and estuary degradation. So although wetlands can improve watershed water quality, their capacity to process pollutants without becoming degraded can be exceeded. So if they cannot process those pollutants at the same rate, okay, that's not good. So many North Carolina wetlands have suffered functional degradation, although it's difficult to calculate the magnitude of the actual degradation. So some of the human activities that do degrade wetlands are urbanization, industrialization, agriculture, which is huge. We've been talking about agriculture a lot in this unit. Marinas, okay, fishing marinas, and mining. And mining's another big one that we've been talking about a lot this unit. So what is an estuary? It's an ecosystem in which fresh water from rivers mixes with salt water from the ocean. So way back in the beginning of this unit, when we talked about the water cycle, also known as the hydrological cycle, we talked about the earth and the water that we find on earth. Do we have more salt water or more fresh water? Salt water, that's right, okay? So a lot more salt water. So we see that in the oceans. So estuaries become a nutrient trap, which is a mineral-rich mud drops to the bottom, okay? And in some areas, marsh grass grows in the mud. Anybody ever been to a marsh? No? Swamp? Anybody ever seen a swamp? Yeah. Next is a marsh. Okay, this is freshwater wetland that contains non-woody plants. So this attracts many types of different nesting birds. Anybody ever seen one at least, if you haven't been to or near one? A swamp. Okay, this is a freshwater wetland that contains woody plants and shrubs. Okay, so the difference, make sure we understand the difference there. So marshes do not have woody plants and swamps do. Water ecosystems. So we've got freshwater, which consists of lakes, rivers, and wetlands, which are swamps and marshes. And then we have our estuaries, which are the mix of fresh and salt water. So if you were to look down here at this image, okay, the blue shows deep water habitats, which you might not see as much of in the state of North Carolina. And a lot of them are on the western side. And then the green, which you see predominantly on the eastern half, are areas of wetlands, okay? So those can make up big portions, swamps and marshes. So what is saltwater intrusion? So saltwater intrusion is the movement of saltwater into freshwater aquifers along the coast. So when we're talking about intrusion, think of it like an intruder. So what does an intruder do? Intrude. So what do? Do they belong there? No. Okay, so they don't belong there. So they kind of just, you know, make their way in. Okay. So this is what is happening here. So saltwater intrusion is salt water intruding into freshwater aquifers. How does it occur? How does it happen? So saltwater has a higher mineral content than freshwater. So because of this, it's denser and has a high water pressure. So we've talked about the denseness. So if we were to take, for example, oil and water, where does do oil and water mix, first of all? No. Where does the oil go? Where does the water go? Yeah, the water goes to the bottom, the oil goes to the top. Do you know why? Which one's more dense then?
I mean,
Water. So the water goes to the bottom. Right here. Okay. So salt water can push inland beneath the fresh water. Okay. So because it's denser, it's going to go underneath the fresh water. So that's going to go below. So do human activities make a difference? Human activities have increased saltwater intrusion in many coastal areas, and this happens via an increase in drilling of fresh water along the coastal area, digging navigation channels, and also digging drainage canals. Sometimes we don't do as much good as we hope, huh? So does weather make a difference? So we've talked a lot about weather and climate. So saltwater intrusion can be worsened by extreme events like hurricane storm surges and the rising of sea levels. So we've talked about hurricanes in here. We've experienced hurricanes where we live, okay? And we've also talked a lot about sea levels rising. So why is saltwater intrusion an issue for North Carolina? The reason that it's such an issue for North Carolina is because it can lead to contamination of drinking water sources. So we drink water. We don't always drink bottled water, okay? So this saltwater intrusion, we don't drink salt water, right? No,
We got that one.
tap water.
Mhm.
Okay, so we don't drink salt water. So because of saltwater intrusion, that can very much contaminate our drinking water sources, which is not good because we do not want to drink salt water. So how do we prevent saltwater intrusion? The use of injection wells, subsurface barriers, and monitoring systems would improve water quality and prevent saltwater intrusion, which you can see in the diagrams to the right. Okay, so up here, you see a pumping well with your aquifer in the top one, which we've talked about aquifers last week. In the second one, we see saltwater wedge, okay, being intruding. So you also see, I want you to note in these diagrams, okay, that this is going under the fresh water. So the darker is the salt and the lighter color is the fresh water. And in each diagram, that salt water, because it is so much more dense, is going underneath. And then in the last diagram, we see the injection well, okay, which is a pressure gradient, which forms that barrier. Okay, does anybody have any questions?